Hello everyone, welcome to our talk. This is Xianzhe from Tsinghua University. Today, on behalf of all others, I'm happy to share with you our work, ContextCam, Bridging Context Awareness with Creative Human AI Image Co-Creation. The rapid advancement of AI-generated content promises to transform various aspects of human life significantly. What about enabling image co-creation between humans and AI by integrating context awareness with mainstream AIGC technologies? The introduction of LLMs and image generation models has further revolutionized the domain of human-AI co-creation. One way to assist the co-creation process is to use LLMs to provide suggestions to generate the text-to-image prompts, such as Opal, 3DOE, and Gene Assist. While these tools successfully leverage LLMs to help users craft ideal prompts and improve the co-creation process, they fail to take advantage of contextual information to optimize the co-creation experience. Context awareness has great potential in image generation, which can improve user engagement and refine their interactive experience. For example, UbiFit Garden and Who is Zuki uses on-body sensing to detect users' daily activities, providing pertinent visual feedback to encourage increased physical activity. As if now we were unable to locate similar work in the domain of human-AI co-creation that combines mainstream image generation tools or models such as Stable Diffusion and Midjourney with context-aware systems. In this paper, we introduce ContextCam, a novel human-AI image co-creation system that integrates context awareness with mainstream AIGC technologies like Stable Diffusion. ContextCam provides users' image creation process with inspiration by extracting relevant contextual data and leverages large language model-based multi-agents to co-create images with the user. Let's use a case to illustrate it. On a sunny night, Alex stands on a bridge above the lake, texting their friend and enjoys the song Counting Stars by One Republic Smiling. They want to capture the beautiful moment, then open the ContextCam and collaborate with it to create a piece of art inspired by their current context. During the framing phase, ContextCam extracts relevant contextual data and proposes 3 themes. Alex selects theme 1, asks ContextCam to create the image, and polishes it through in-depth discussion with ContextCam. We first conducted a formative study to gather design insights for context-aware human-AI co-creation system from participants. We hope to understand the prevailing motivations and needs for AI image generation, the limitations of current AI image generation, and participants' vision for a context-aware human-AI image co-creation system. Participants expressed their concerns about the trade-off between image quality and interaction complexity in AI image generation. 15 participants found crafting the proper input prompts challenging and often had trouble creating desired images. 5 participants mentioned that some natural language-based image generation and editing systems don't always meet their expectations in terms of output quality. Another issue is the personalization of AI-generated images. We invited participants to envision a human-AI co-creation system capable of creating images inspired by personal context. First, we asked the participants to imagine co-creating images with AI in different scenarios. We identified 5 types of contextual information commonly mentioned: location, facial expression, music, screen content, and the weather. Next, we asked them about their expectations for experience design. We summarized the 6 design guidelines for context-aware human-AI image co-creation system. First, require less user burden, such as fewer text input and click count. Integrate shortcuts for frequently used tasks, and use a conversational interface to make interactions more natural and efficient. It would be preferable for the system to run on mobile devices. Design a well-functioning intent understanding and image generation mechanism. Ensure the system generates high-quality images by adhering closely to the user's needs and preferences. Accommodate a variety of input methods, including voice commands, textual input, and image-based inputs such as photographs and sketches to enhance usability and convenience. Offer a range of suggestions to others. Each conversation should start with several brief image topics and develop detailed suggestions based on user feedback and interaction. Focus on the most relevant contextual information based on user intent and consider excluding less relevant context to optimize user experience and reduce information overload. Allow users to control which contextual information is utilized by the system and apply a clear visual indication, such as dimming unused contextual icons to show when certain data is not being employed. In response to the complex procedures and knowledge required for image creation, we adopted a multi-agent system design. LLM serves as the brain of each agent in our system, and each agent is responsible for a distinct task, potentially integrating one or more of the following components: planning, memory, tool use, involving. This figure shows ContextCam's workflow. The system comprises 2 creation phases: framing step 1, 2, and focusing step 3, 4, and 5 agents: context selector, topic agent, tool manager, artist agent, and personalization agent. From John Dewey's ArtX experience, we learned that image creation is deeply connected to its environment. Our system, ContextCam, exemplifies this idea by being context-aware and drawing inspiration from its surroundings. However, as shown in the figure, not all contexts are relevant to the subject of the user's drawing. We introduced the context selector to prevent such issues. Context selector leverages LLM to select contextual information relevant to the current art creation process. We adopted the few-shot chain of thought approach to improve LLM's ability to solve complex problems, where LLM performs chain of thought reasoning with several demonstrations. To evaluate the performance of our system in practical settings and understand user behavior patterns within it, we conducted a real-world user study with 16 participants and 136 scenarios. There are some images from the experiment that users found satisfactory. Figure 7 displays the post-experiment questionnaire ratings from participants. After each conversation, we collected self-reported user satisfaction with the images on the 7-point Likert scale. And Figure 8 shows the user satisfaction ratings. The average user rating was 5.8, indicating a relatively high level of satisfaction. To evaluate the ability of ContextCam to infer user intentions, we examined the percentage of conversations where users selected recommended topics and conversations where they proposed custom topics. Figure 10 displays the distribution of users' final theme selections. For all conversations, user-picked system-generated topics 92.9% of the time. To evaluate the user's interaction burden with ContextCam, we calculated the number of input words, clicks, and interaction rounds for each conversation. Then we calculated the ratio of input words to interaction rounds for each conversation. On average, this ratio stood at 1.1 for single interaction, indicating a low interaction burden. Then we delved into users' interaction behaviors with ContextCam and their feedback to uncover insights about the behavior patterns demonstrated by the users and how context awareness affects human-AI co-creation. Participants varied in their frequency and preference for using different types of contextual information. Factors such as traveling events, lifestyle, and personality influence the results. Participants enjoyed using contextual information to create images. Contextual information affected users' image theme preferences. Users frequently weaved in their personal experiences and preferences. For example, when users created art under specific weather conditions, they may unconsciously associate their moods and themes with the weather. As learners gained familiarity with ContextCam, they were more likely to actively customize and leverage context awareness in image creation. Context awareness made the collaborative process more enjoyable and efficient, resulting in distinctively personalized outputs. Here, creation is no longer an isolated behavior. It is co-shaped by external environments, emotions, and interactions between users and AI. Context awareness fostered emotional resonance and encouraged users' engagement in human-AI co-creation. Users perceived an enhancement in their creative processes due to context awareness, and the themes recommended by ContextCam amazed them. ContextCam employed contextual data to create images, vividly showcasing aspects of users' local natural environment, cultural landmarks, and historical context, and so on. To sum up, our work presents the preliminary application of context awareness in human-AI image co-creation. Of course, it is important to know that there are many areas for improvement in future work, such as deepening context awareness, optimizing co-creation, and inspiring co-creativity, and innovating interaction modes. Thank you so much for your interest in our work. Feel free to check out our paper and let us know if you have any questions or feedbacks.